7, Unit 2, Solving, Lesson 10, Part 1. Multiplication property of inequalities. Case 1, positive factors. The multiplication and division properties of inequality. Case 1. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. For example, negative 4 less than 6. If I multiply both sides by 2, I get negative 8 less than 12. There's no problem there. So, in general, if A is less than B, and C is a positive number, then AC is less than AB. If A is less than B and C is a positive number, A divided by C is less than B divided by C. And the same works for greater than. So let's look at our first example. X divided by 5 is less than or equal to negative 3. We would multiply both sides by 5. And x divided by 5 times 5 is x. So we get x is less than negative 15. And that is our solution. And you can see a nice graph of it. The boundary point is included. So it's filled in. And then every number less than, we draw the arrow facing the less than numbers. Now let's go ahead and check a solution here. If we pick the number negative 30 and try it out into the original equation, negative 30 divided by 5 less than or equal to negative 3. This is negative 6 less than or equal to negative 3, which is true. That is true. Okay, solve the inequality, graph the solution. N divided by 3 is 1. We need to undo the division by 3. We can do that with a multiply by 3. Multiply 3 and divide 3 become 1. So 1n is less than 3. We get n is less than 3 as our solution. Let's go ahead and make a graph. The most important number on this number line is going to be the number 3. I'm going to put some additional numbers on. And 3 is not included, so I'm going to have an open boundary. N is less than, so I need to draw my arrow to the smaller numbers. Let's go ahead and check a solution real quick. Let's try the number 1. 1 divided by 3 is less than 1. Well, that's 1/3 less than 1, which is true. Let's move to our next example. Negative 0.5 is less than or equal to 10. To get rid of the divide by 10, we need to multiply by 10. 10 times negative 0.5 is negative 5, and that's less than or equal to m. 10 divided by 10 reduces to 1. All right, so m is greater than or equal to negative 5 if we put the m first. The graph of this, we need to have the number negative 5 on our number line. I'll go ahead and count by 5s. And let's see, it is a filled in, so it is a closed boundary. And m is greater, so the arrow needs to go towards greater numbers. And we pick a solution and check it. Let's check 0 out. 0 is an easy number to multiply or divide with. Well, you can't divide by it, but everything else is okay. So is negative 0.5 less than 0? That is true. That's true. Okay, number 3. Negative 3 is greater than 2/3 of p. I need to multiply both sides by the reciprocal, 3/2. That's going to get rid of 2/3. So I get 1p. And 3/2 times 2 is negative 4.5. So p is less than negative 4.5 if we put the p first. And then graphing it, I'm between negative 5 and negative 4. So I'm going to kind of space my number line nicely here. And halfway between negative 5 and negative 4 is negative 4.5. It is an open boundary. And p is less, so we need to draw the arrow towards the smaller number. Excuse my hiccup. And then let's pick something that's easy to multiply by 2/3. How about negative 6? So is negative 3 greater than 2/3 of negative 6? Well, 2/3 of negative 6 will end up being negative 4. Is negative 3 greater than negative 4? That is true. Okay, 6x is greater than negative 18, and then we're going to graph the solution. We can go ahead and divide by 6 on both sides, and this gives us x is greater than 3, which is our solution. If we take a look at the graph here, there is an open boundary at negative 3, and since x is greater, the arrow goes towards the larger numbers. Let's go ahead and check a solution. Let's try 0. That's on the line. 6 times 0 is greater than negative 18. Well, 0 greater than negative 18 is true. So that does check out all right. Solve the inequality, graph the solution. 4b is greater than or equal to 2. We need to divide by 4 to get b by itself. So b is greater than or equal to positive 1/2. As far as the graph of that goes, 1/2 is right here between 0 and 1, and b is greater, so the arrow needs to go towards greater numbers. And there's a graph of it. If we try one of these solutions real quick, try 2. 4 times 2 is greater than or equal to 2. Is 8 bigger than 2? Sure is. Next example, 12k is less than or equal to negative 24. I'm going to divide by 12. I get k is less than or equal to negative 2 as a solution. Negative 2 is going to be my most important number on the number line here. And it is included, so it needs to be a closed boundary. And k is less than, so it's going to go in this direction. K is less than. And just picking a number to try it out, let's try negative 3. 12 times negative 3 is less than negative 24. That's negative 36, less than or equal to negative 24, which is true. Okay, let's move on to the next example. Negative 15 is less than 2.5q. Divide both sides by 2.5, and that gives us q. And 15 divided by 2.5, I want to say it's 6, but I'm going to double check real quick. Well, negative 6 in this case. And it is negative 6. I'm going to rewrite it so the q is first. And then at negative 6, let's go ahead and label by 3s. It is an open boundary, and q is greater, so the arrow is going to go in this direction. Let me go ahead and check a solution. I like the number 0. Negative 15 is less than 2.5 times 0. Negative 15 is less than 0. That's true.